Now there's four different types of fronts. There's warm fronts, cold fronts, stationary fronts, and occluded fronts. Now the first kind of front we're going to talk about is a warm front. This is when the warm air mass advances on the cooler air. Now what happens then is the warm air is going to slide over top, and notice it turns into rain and clouds. A lot of times people think a warm front, oh, it's a warm front. I better be getting my bathing suit and sunglasses. No, you're going to have a weather system where it's raining because it's the collision of the two air masses right here that causes the weather to happen. But it will slide over it. Okay, get your pen, paper and pencil out. You should have that written down. Let's draw a picture. Okay, the first one here is a warm front. And what a warm front is, you got to draw what I draw. So here's the ground, and here's warm air, okay? The warm air, and here's the cooler air. And this one is advancing. The warm air is advancing over the colder air. Now, which one's going to go up, the warm air or the cold air? That's right. The warm air is going to slide over the top of the cooler air, right? And so what you end up with then, as it goes up, it's going to condense into clouds, and sometimes it's going to rain, okay? So not always rainy, but the warm air slides over top of the cooler air. That's a warm front, okay? Bingo. Okay, so here again, I kind of like these pictures. I don't think we were able to draw pictures quite as good as this, but that's basically the idea. As it gets pushed up, it's going to reach the dew point, it's going to condense, and it's going to rain or snow. A warm front. Now the second type is called a cold front. This is a cold air mass advancing on the warmer air mass. Again, write this down. If it's white, you gotta write. Now, with your paper and stuff, draw the picture just like me. Okay, now a cold front is kind of like a warm front, except for the big difference is the cold air is advancing onto the warm air. Now think what's going to happen then if you have the cold air advancing on the warm air. The cold air on this side here, and here's warm. Now this is relatively cold and relatively warm. The warm might be pretty, might be like only 30 degrees, but if the colder is colder than that, or, at any rate, it's relative. The cold can't slide underneath the warm. That won't work. And so what it has to do when the cold air advances on the warm air, it's just going to have to push the warm air up out of the way. And because it does that, that rising air moves a lot faster up and it's a lot more likely to form a cumulonimbus cloud. That's a thunderstorm. Okay? And so it's going to tend to be stormier and rainier than a warm front is. That's called a cold front. Okay, please draw that picture. The cold air advancing, and notice how it doesn't slide smoothly. It's a lot sharper. Now the third type of front is called an occluded front. This is warm air is pinched between two colder air masses. And so have your pencil ready. I'm going to draw a picture here and describe it. This kind of front here is a little bit tricky. I know you've heard the word warm, you've heard the warm cold. Those are easy words to remember. This one is occluded. What occluded means is to be caught in between two things. An occluded front. And that's what happens. Basically what happens with an occluded front is you have a warm front, and then you have a cold front that advances and catches up with the warm front. Okay? And so here's cold air, moving in this direction. So that's like a cold front, right? It's rounded. But remember how the warm front is like a smoothly moving thing? Well, here's where it caught up with that. And so this would be a warm front. So here's the warmer air. Okay, so let's just call this cool air instead of cold air, okay? Because the warmest of the air is this one. And so what happens is now it gets caught between two cooler air masses and it just gets pushed right up into the air. And this is where you have real serious thunderstorms. It's where it's pinched off. It's usually spiraling in counterclockwise. And this is the kind of front often will produce things like serious weather in tornadoes even. okay? And so an occluded front. Now the other type is called a stationary front. The air mass is sliding past each other. Now the air is moving, it's just that the place where they're colliding into each other isn't moving across the earth. They're moving sort of across, sort of in opposite directions of each other. Okay, so this is the tricky one to draw, but I bet you can do it. And here it comes. Now a stationary front. A stationary front is the hardest of the bunch to write or to draw a picture of. Stationary front. Now in a stationary front, let's see if we can manage to do this. Here, let's say you have the cold air here and the warm air here. But instead of it being like a side view, we're going to try to make this like more of a top view, a topographical view, where the cold air then is going to be sort of going this direction, an arrow moving into the paper. Okay, and then the warm air moving this way. And so the boundary between them. And so this is like a 3D view. We're viewing it kind of isometrically, like looking down. Because the front itself sort of stays in the same place and position of the Earth, but it's just air moving across each other like that, okay? So a stationary front stays in one place. Doesn't mean the air is not moving. It just means that the front, the location of where the two air masses are hitting, doesn't move. If it was going this way, it would be cold air, a cold front. If it was going this way, it would be a warm front. All right.